Okay guys, morning. If you're seeing this, it's Saturday morning and I've just sent you your papers back no more than an hour ago. So question one, this is our paper one. We'll be doing this in class if we were in class. And so let's do it now. I can't take questions obviously, but you can obviously pause the video in YouTube and look at everything really slowly again, and I might teach it faster than normal because you can just go over it many times. So number one, circle calculation that decreases 250 by 15%. If I'm going to reduce something by 15%, I can work out 15% of 250, then take it away, or I could just multiply by 85% straight away and that will be reduced by 15%. So that's the correct answer. Next one, solve this little animal. Okay, looks very ugly. How about 3x minus 2x, bring this over, equals 0, so x equals 0. That's your answer. Number three, too many of you actually did this, either in your head or you guessed. Listen, I know it's only 1 mark, but you're in an exam and it's under pressure. So you need to get the 2x values added and then halved because you're averaging out the distance across. And you need to take the 2y values added and divide by 2 to average out the y difference. So that's going to be, what's that going to be? 12 over 2 is 6, 14 over 2 is 7, 2, 7. And there's a fair bit of work just for 1 mark, but it's grade 4 and they won't give you any more for it. Too many of you got question 4 wrong. The reason you got it wrong is because some of you went for this one because you went 2 times 4 is 8. Well, it's not a 4, that's a power of 4. This means 2x times 2x times 2x times 2x. 2 times 2 times 2 times 2 is 16. X times x times x times x is x to the power of 4. Okay, I think one of you went for 6 as well. You said 4 times 2 is 6. Again, that 4 isn't there at all. It's a symbol meaning multiply again and again and again and again. All right. Many of you were tricked by this. I'm given this little equation. I'm also given this expression. I've got to work that out. So here I go. Well, I don't know if you can see this, but actually b is the same as 60 times a. Can you see that? If you put this into a normal way of writing it. So I've got, so 4 b's is going to be 4 lots of 60 times a. There it is, okay, 4 b's, 4 of these. A's cancels straight away because it says divide by a, and 6 4s are 24, answer 240. Again, too many mistakes for this one. So 27 is 3 to the power of 3, and when you get this kind of scenario, it's 3 squared times 3 squared times, 7 times over. So 2 7s are 14, add the 2 powers to get 17, 3 to the power of 17. Very easy, 3 marks there. This one I found difficult. I mean, ratios are difficult, and plus half the page is taken up by story. So this guy's making rose pink paint and it's also cherry pink paint. These are the ratios of red and white paint to make the 2 versions of pink, and this is what he's doing. He makes 60 litres of rose pink paint. To this rose pink paint he's going to add 80 litres of red and 28 litres of white. Has he successfully managed to make, in the correct proportions, cherry pink paint? We need to show how working. So I'm now working with rose pink. So R to W is 1 to 2. I'm merely quoting that because I know I need to share 60 litres in the ratio of 1 to 2, which straight away is 20 to 40. Fair enough? I'm now going to add 80 litres of red. Now some of you added the wrong amount of paint to the wrong colour, so you got very confused and you lost everything apart from a single mark. So I'm adding 80 onto the 20. Why is that? 80 red onto the 20 red gives me 100 red. I'm adding 28 litres of white onto my 40 litres of white, comes to 68. Well, 100 to 68 is not the same as 4 to 3, and that's sufficient to get all 4 marks. So you can try simplifying down if you want to. So I've got 50 dot dot. I mean, dots are terrible on this machine. That's, what's that, 34? I think I can halve again. 25 dot dot, come on dots, What's that? 2 17s? I can't go any further. So that is clearly not the same as that. So no is the answer for all the above reasons to get 4 marks. Very, very easy. That's why it's only 2 marks. Some of you don't know that 2 divided by 8 is a quarter, which is 0.25. 14 take away 9, power of 5. That gets you 1 mark because you've got a step that's correct. Now, that is not standard form. To get into standard form, you've got to move this over to the right, which means you've just multiplied by 10, which means that's now going to become a power of 4. There's your 2 marks. If you got this wrong, go and study it. This was just a bit of a brain teaser. I've got this horrible number split up into 2 parts. Well, that's helpful actually, because 6,200 is going to be 6.2 times 10 to the power of 3. So the power C must be a power of 3. And this is 0.07. So 0.07 is 7 times 10 to the power of minus 2. If I go back, if I take 7 and I go back 2 steps, boink, boink, I will get my 0.07. So there's your 2 marks, a mark for each. This was really easy. You substitute for each value of t, 1, 2, 3, 4, 60 over 1 is 1, 60 over 2 is 30, 60 over 3 is 20, 60 over 4 is 15. Then you just plot the points, and it's clearly not a straight line graph, and you're therefore supposed to draw a curve. 2 marks for the plotting and the curve. 3 minutes 30 seconds is 3.5 minutes, so you need to evidence on the graph where you're getting your answer from. If you just wrote down an answer, you get nothing for that, nothing at all. You've got to evidence it on the graph, and then after having done that, you will get a mark for a half decent answer. Mine's 16 because every little square, I don't know if you can see that, is worth like 2. I'm 2 squares away from 20, so I must be 16. I didn't mind too much what you put there, provided you evidenced it on your curve. And of course, if you don't have a curve, you can't read off it, so you get no marks for that. So that's that. Again, a long question, and it took me a while to get this right. I mean, congratulations to you, got 27 as a final answer. So boxes of buttons, 45 are large. Yeah, 45 are large, both green and yellow, 45 in total. Some are yellow and the rest are green. The number of small is 5/3 of the number of large. That's going to be useful later. The number of greens is 300% of the number of large. In other words, 3 times as many greens. I better write that down there. So, yeah, if I put there times 3, I'm sure I'm going to use that later. And there are 12 small buttons. Are there? Oh, they told me there's 12 small buttons and there's 45 large. How many green buttons altogether? Right, let's just do this bit. My first step was, I mean, that should say 45, but I was jumping ahead there to my answer, so that should actually be a 4 there. All right, so it's 5/3 of 45 to get my large buttons. So 3 and 45 cancel. It goes in 15 times. 5 15s, 75. Then I put it there because it could be useful, and it is useful because if I've got 75 small buttons in total, based upon this bit of information here, then I must have 63 small green buttons. So I've got a 45, a 75, a 63, a 12, and I'm on a roll. Now, what's all this x and 45 minus x rubbish all about? Let's read the story. How many large green buttons are there? I don't know. X, that's the whole point. That's what I'm trying to work out. So how many large yellow buttons are there? I don't know. But if there's 45 large buttons in total, then yellows must be 45 take away x. Makes sense? Now I've got all the ingredients I need to bake my cake, or should I say, set up an equation. So here I go. 63 plus x, that's all the greens, equals 3 times the number of yellow buttons. And the yellow buttons are 45 minus x plus 12. Is that okay? That's the yellow buttons. 45 minus x plus 12. If I multiply that by 3, I will get the same as x plus 63. Yeah, I knew that would be important. They won't give you anything that's not essential for calculating. So there we are. I'm going to set up an equation. So 3 lots of yellows. Is that correct? Yeah, 3 lots of yellows. 45 and 12, 57 minus x. Multiply out. 171 minus 3x. Bring your minus 3 over and add it. Take your 63 over and subtract. Divide by 4. 27 large green buttons. Not that we really care, but we want 4 marks, don't we? Alright, so you can look at that more slowly. I'm going quickly. It will take a day to upload this video, I'm sure. 11. This requires a lot of careful reading. That's me making a mistake. The product, that means multiply, of half of a number. Now, we're told the number is y. Don't use n, don't use x. Don't do that. If they want you to use y, use y. The product of half the number, oh, that's y over 2, or half y, is 3 more than the number. In other words, y plus 3. Not 3y, 3 more. If I'm 3 years older than you, then I am x plus 3. Is that all right? Y plus 3 in this case is the same as the square of the number. Well, that's y squared. So that's half the number. That's 3 more than the number. Here I'm multiplying, because I didn't put a plus there, because product means multiply the 2 together, and that will give you the square of the number itself. There it is. So I gave credit where credit was due. You had to get it all right to get 2 marks, obviously, and there's your final answer. And I thought I'd try and simplify, and I don't know, I wrecked it. That's it. Toby, he can't do maths. So there's nothing wrong with this equation at all. He brought the 8x over and multiplied. So far, so good. Then he tried to square root the 9 before dividing by 8. You can't do that. How can you square root both sides to get the x on its own without the 8 being square rooted? First, take the 8 over to the other side. So you're going to get this. Actually, Toby should have done this. X squared is 9 over 8. And then you can square root it, Toby, and then you won't be quite so useless at maths. And of course there'll be a positive answer and a negative answer. Cool? What did I say? You should divide 9 by 8 first. For 1 mark, I'm not going to fill up the lines with stories. Don't do that. This is the difference of 2 squares. They have even done this for you. Come on, you know how to do that. And therefore you apply that to this. So 197 plus 7, 193 minus 7, that comes to 200, that comes to 186, and too many of you don't know how to multiply. It's 2 times 186, do a little scribble down there and work it out, and then stick 2 zeros at the end. There it is. It's no more messy than that. This is still the difference of 2 squares because it's part of the same question. And you got really messed up on this. Too many of you messed it up. Well, that's a square expression. The square root of 100a squared is 10a and 10a. Got it? 10a, 10a. What about 81b squared? 9b, 9b. Done. One's a plus, one's a minus, because it follows this identity, all right? You know this, you've done it in class. If you got it wrong, you didn't revise. That's that. I'm not even going to tell you any more about that. This is a little bit tricky for one reason only. First of all, factorise here and here. We can take out a 4x from each, leaving you with this inside the bracket. Test it. 4x minus 4x times 2x minus 8x squared. So that's good, but you haven't got a mark yet for sure. Factorise this. I think you can pull out a 6, leaving us 2x minus 1. That's worth a mark, I'm sure. Now, what you may not believe is that these do cancel out, but they give an answer not of 1, they give an answer of minus 1. I'll prove it in a moment. Hopefully the video won't be too long. So the answer is minus 1 times 4x over 6, which is minus 2/3 over 6. In fact, try it yourself. Substitute any number you want for x there and there. Then divide them. You will get minus 1, I promise you. Try it out. This is an unconventional simultaneous equation. That is to say, you can't get an answer for x or y, but you can in terms of p. It's a little bit edgy, way more than grade 5, into grade 6 easily, because they've done something strange to it. So you've just read that. P is not going to change, so the p there is the same as the p there. Give your answers in terms of p and simplify as much as you can. Now, in order to eliminate one of these letters, I said, well, if you're a y, you're the same as this y here. So I said 2x plus 3 lots of y, yeah, because y is this part, is 5p. Multiplied it out. I got 8x equals 2 lots of p by taking the 3's over there. Divide by 8. 2 over 8 is a quarter. It's not 4. Some of you put 4. No, it's naughty. It's a quarter of a p. Whatever x is, it's a quarter of the value of p. Put it on the dotted line and get your mark. Now, if x is a quarter of a p, it's easy to work this next step out, because I can write down here, to get y of course now, 2 times a quarter of a p plus a whole value of p. That's what I've done. 2 times a quarter is a half. Half plus 1 is 1.5 p's, or 3 over 2p, if you prefer top-heavy fractions. I think they're really ugly. Much prefer mixed numbers. Excuse me. Right, what's this next one? 16. That's on line L. That's 2 points on line M, and thankfully they are parallel, which means, you guessed it, they have the same gradient. And since I have to work out the equation of line L in this form, I better work out the gradient of line M and donate it to line L. Well, they've done it a little bit too pointy there. I want to come over here, do it nice and big. So from 4 to 6, I've got like 2, and from 0 to 10, I've got like 10. Oh, the gradient is 10 over 2, which is 5. So straight away, I've got y equals 5x plus c. Now, don't be careful. I don't know what the intercept of this line is. Don't put 10 there. It does not belong there. This is the point minus 310 on the line L, all right? So, but I do know the point 10 minus 3 is on the line L, and I know the gradient of line L is 5. So, there's your 10, there's your minus 3, minus 15, plus it, c is 25. 3 marks, y equals 5x plus 25. This is quite easy. You can multiply this side first to get that, and then multiply by 3. I think that's what I did anyway. Yeah, so once you got this, you've got a mark, take over the 3, multiply this by 3. I took my x to the right and subtracted. I took my 60 on the right and brought it to the left and subtracted. So I've got 5x equals minus 45, divided by 5 is minus 9. You could in fact do this if you're so inclined. So I could have gone x take away 6x is the same as 60 ping take away 15. So I get minus 5x's. Here's the same as proper 45. And when you divide, you end up with 45 divided by negative 5, which still gives you a negative 9. There it is, 4 marks. It's not difficult. What's next? This is just ridiculously easy for 2 marks. It is a grade 7 factorisation, admittedly, but it's not difficult. What some of you need to hear is the fact that once you think you've got it, think again, because you might have put the plus in the wrong place and the minus in the wrong place, and it will never get you back to the beginning. So use the space to test it out, and don't forget to write your answers on the line. This was actually really well done, and it's so easy because that's all positive. That in its own name is a grade 5 quadratic equation. These are the factors. This is a grade 6 quadratic equation, difference of 2 squares, and the x plus 2's cancel, leaving you with that. Put it all together, that's a grade 7 question. This you've seen before because we did it in Exam Pro. I didn't take it from Exam Pro, I just found it in one of the papers that AQA had set. You'll recognise it if you're set 1 because you would have done this. So the average acceleration during the 50 seconds, work it out and give the units. Well, I better shrink it down so I can talk a little bit better. No, that's terrible. Make it a bit bigger. Well, that'll be 30 divided by 50. Please don't ask me for a mark if you just write down 30 divided by 50. At least simplify it down to 3/5 or 0.6. And acceleration is in meters per second. In other words, meters per second squared. So there it is. Next little bit. Too much reading. I've got to find during this 50-second dash where the instantaneous acceleration is the same as the average acceleration. Well, you need to show the average acceleration by drawing in the line as if it was going at a constant acceleration, right? But it's not constant. It gets faster, then carries on going faster, but not at such a high rate. So draw in that line and then get your ruler and put it across the curve somewhere and make sure these two gradients match. Again, it's just done visually. There it is. That's the average acceleration. This is the instantaneous acceleration at the point where time equals 12 seconds or thereabout, okay? I think I did a good job there trying to get these gradients to look the same, but I didn't quite touch my curve there, so they should be down a little bit more, right about there somewhere. So line it up really carefully with your eye and with your ruler. You get a mark for a decent gradient and a mark for evidencing that it's about 12, 11, 13, depending on your actual gradient. So that's that. 4 easy marks, actually. There we go. Convert that into a fraction in its lowest terms. Well, I've got 3 decimal places there shown. Of course, this keeps on going as 727272727272 forever and ever and ever and never seems to want to stop. So as I taught you, and some of you did a decent job on this, allow x to be worth that. If I jump over times 1,000, 1,000 x's will be bam, bam, bam. That's now a whole number. And all the 72s continue, all right? They just keep going, 72, 72, 72. Now, it's not 1,000x take away a single x, because as you can see, after the decimal point, there's a 7. And after this decimal point, there is a 1. So they don't line up properly. But if you multiply this by 10x, this goes over to becomes 1.72. Now look at this. 1,000 x's is that. 10 x's is that. When you subtract now, the 72s are completely in line. So if you subtract 10x from 1,000x, 990 x's. 172 take away 1 is 171. And all these 72s go on forever, get eliminated. And then if you possibly can, try and simplify this. Now, it's awfully tempting to pick up your calculator and do this last step. I wish you didn't, but you probably did. The way to go from there to there is to break it down into steps. Try dividing this by 3 and try dividing that by 3. And then you can divide that middle step by 3. You will get to that. All right? What's next? Yeah, I had a whole page to do this, so I took my whole page. So here I go. This is quite long for 4 marks, and it is actually a non-calculator question. So if you use the machine, you're very naughty. So root 18 is root 2 root 9. You can probably see I put a 5 under there for some reason. So root 2 root 9 is root 18, which is 3 root 2s. I've got a mark, I'm happy. To rationalise this denominator, because you can see there's no roots underneath there, it's got to look something like that. So I've got to multiply top and bottom by root 50 and root 50, all right? Well, root 50 times root 50 is just 50, and I broke up my root 50 into root 2 root 25, which is 5. Here I go. Next step. I went 5 times, I think actually I could have done 5 times 28. I found that a bit challenging. So I thought I'd divide away the 5 and the 50 to go 1 over 10. So at least it's smaller numbers. Then I divided it again, dividing by 2's top and bottom to get even smaller numbers. Then I thought, can't go any further, unless of course I include you over 5. So if I'm going to put divided by 5 onto this surd here, I better multiply the numerator by 5 as well. So I've got 15 root 2's take away 14 root 2's, which is a single root 2 over 5. There it is, 4 marks. Okay, so turning points are terrifying. A turning point of the curve is at A8. Okay, well, if I do a completing the square thing, I've got x minus 3 with x minus 3. If you want me to demo, I'll try and do it here. So I've got x minus 3 with himself. Yeah, I'm trying to make a square, and that's going to give me x squared minus 6x plus 9. How do you get from plus 9 to 17 plus 8? They told us that anyway, but here we go. So I want the a value. Well, there it is, right there. A must be worth 3, because 3 minus 3 makes 0. Then that will give me either the maximum point or the minimum point. Either way, it will turn. If it's an x squared graph, the 8 will be there. If it's a minus x squared graph, the 8 will be there, but it's positive, so this is the scenario we're looking at. Anyway, 2 marks, that's quite easy. This ain't difficult either for 2 marks. The turning point on this curve also has a y coordinate of 8. Oh, that's good. Work out the value of b. Alright, so I took x plus 2 squared and got this out of it, so at least I can match my x squared and my 4x. Now, this is the bit where some of you made a mistake. If that equals 8, of course, y equals 8, it says so. So that's why I took it over and made it minus 8 on this side. So it looks like a quadratic equation I'm about to solve. Now, as you can see, b minus 8 exactly matches the 4 there. This is called algebraic equivalences, and we did that time ago back in year 10, and we're still in year 10, I'd say. So b minus 8 is 4, hence b must be 12. 2 marks. I think there's a lot of work for 2 marks there. What's next? This is easy, but obviously I can't do it because I made a mistake. 8 is 2 to the power of 3, which is already powered up to 4. So this is the first step. And 2 to the power of 4 and 2 to the power of 3, when combined together, is 2 to the power of 12. I'll put 8 there. I don't know why I did that. This is 32 to the power of 1/5 that's later squared. And a power of 5th means find the 5th root of 32, which is 2. And 2 squared is 4. So we don't want to go to 4 because they want it in terms of 2 to the power of whatever, m. So now subtracting powers, 2 to the 12 divided by 2 to the 2 is 2 to the 10, and now I've got my 3 marks as opposed to nothing. Well, I might have got 1 for that maybe, I don't know. But now I've got all 3 and I'm very, very happy. What's this? Sorry for putting this in. We have not done the whole of year 10, so I was scraping around trying to get you to do a full paper on limited teaching. Although we've done most of year 10, we've got chapter 18 and 21 to do. I couldn't test any of that because, hey, we hadn't done it, wouldn't be fair. So it's a bit unbalanced, the paper, in terms of the amount of the kind of questions I'd have to reset in a different format, in a different context. But it's a turning point question again. This has an x-coordinate of -2. The turning point has got an x-coordinate of -2. So if x is -2 there, a must be worth +2, because -2 plus 2 is 0 to give us the biggest possible value of b. All right, or rather, is it the biggest possible value? How will this look? Let me have a look again. Let me just think again. This will be a positive x squared graph, so it looks something like that. And b will be right there. Yeah, that'll be the minimum possible value of b, not the maximum possible value. So in other words, whatever b is going to be, it's never going to be below that point there. We don't know what that is yet anyway. So I don't know. I did it in a really dumb method. Another point on this curve somewhere is the point 3, 1. So y is worth 1, x is worth 3. Now, so I substituted blindly. So there's my y is worth 1, there's my x is worth 3, and I really didn't need to do this bit. I've got to put a b there because I've got to work out this new y value, the y coordinate. So watch this. I know that x is 2. I should have immediately put 2 right there and stopped being stupid. What I did was multiply it all out, and then I decided to multiply it all by, put the 2 in. So 6 2s are 12. 2's, anyway, I should have done this. 1 equals bracket 3 plus 2 squared plus b. 1 equals, what's this? 5 squared, 25 plus b, from which b equals, take it and minus it, minus 24. And if b equals minus 24, that's the same as the y coordinate being minus 24. Is that all right? Because y equals x plus a squared plus b. Remember, these are real numbers. So the missing b value, the y coordinate for the minimum point, is minus 24. Therefore, this coordinate here is minus 2, minus 24. I'm sure we can all see that. Anyway, the answer is minus 24, and a few of you got it. What's this? Now, all right, it's grade 8/9, but we've done this, and it's 6 marks. You're combining a quadratic with a linear equation to solve for x and y. You can't add or take away to eliminate anything. You need to combine them. And I did it in those steps. So here's the first bit I did. I said y equals 5x minus 5. So I get everything in the form of y. I substituted my 5x minus 5 right here where it says y, whereby eliminating anything to do with y's. And so set up an equation with x. So 2 lots of y, there it is there, minus x squared is 11. Multiply out. Nobody wants a minus x squared, so take everything next door. Plus x squared minus 10x plus 10, which is what I did. And of course 10 plus 11 is 21. I'm left with a very, very, very basic grade 5 quadratic. But in this context, this is grade 8/9. Factorize it, and before you go any further, check that it works by multiplying out again down the side or in a bit of scrap paper. That gives me 2 solutions. X is 3 and x is 7. If I know x is 3, I just shove a 3 in there and get y is 10. If I know that x is 7, I just shove a 7 in there and get y is 30. Is that all right? Let's take a look. I think, no, actually I use that one. It's even easier. If I know that x is 3, 5 3s are 15, take away 5 is 10. If I know that x is 10, I may as well put it in the proper rearranged one, make life easy. So 5 lots of 7, 35, take away 5 is 30. What I like to do is to combine the 2 pairs. So when x is 3, y is 10. When x is 7, y is 30. Of course, you can do this slowly yourselves. And finally, this really did come after this question, actually. Can you believe it? It's that easy. Therefore, this has got to be rated grade 9. And of course, many of you got it right. Negative power means 1 over. It's a reciprocal. And you know that a power of a half means square root. So 1 divided by the square root of 100 is a 10th. And we've done it. And that's our paper 1 done. Right, now I need to have a cup of tea and maybe do paper 2.